Good afternoon, everyone. I hope you all can hear me. Yes, so sorry to keep you guys waiting. We were just waiting till everyone joins. So yes, so we warmly welcome you all to our very first IGCSE Grades Booster webinar. And my name is Shanali and I represent Tutopiya. So before we move on to the content for today, so I'd like to give you an overview of this program. So this is actually called a Grades Booster program. And we hope to focus on topics where students have common misconceptions, for example, algebra, trigonometry, and so on. So those are areas where you actually get questions where you have to score a lot, and sometimes the concepts are a bit difficult to understand. So we hope to focus on those areas specifically. And so what we plan to do is it's a short-term program before your exams are up. So you can prepare for past paper questions. What we've noticed in past papers is that most of the time the questions are quite repetitive, as in they may change the figures here and there, but the types of questions that you get are actually pretty much the same every year. So that's pattern that we've noticed in past papers. So if you practice more past papers, it's going to definitely help you with your exams. So that's our main focus in starting up this program. So that's actually about the program. And so some of you may be students at Tutopiya already, and some of you may be new to the program. So in that case, I would like to speak a few words about Tutopiya. So we actually provide live online personalized classes to students. So based on the subject, on the curriculum that you are doing, we provide you the tutoring services. So, okay. So why choose Tutopiya? So our lessons are live, as I mentioned, and we focus mainly on making the lessons interactive as possible, keeping our students engaged, and making it a two-way, making our lessons more interactive through having two-way discussions. So that's our main area of focus when it comes to teaching. So rather than where the tutor continues the teachers, we focus on making the lessons more interactive. And our tutors are certainly of very good experience and also they have professional qualifications and all the education qualifications needed, and they've experience in different curriculums and subjects. And so we have tutors available for different subjects, for different curriculums, so subjects and curriculums on demand, and we can provide you a tutor according to your own personal needs. And we customize study plans, so we get together with the tutors, and according to the curriculum that you're setting for, we customize the study plan for the number of hours that you have registered with us. And yes, so we also have a student tutor resource portal where the tutor can share homework, share notes, any other material onto the portal, so that the student can also access. And you can do your homework, you can upload it on the portal so that the tutor can check and make any corrections and get back to you with the feedback. And also our lessons are recorded, so that gives you the opportunity to listen to the sessions whenever needed. So let's say if you need to go over some notes again, or if you need to just reflect back on what you have done last week or last month, you still have access to all your lesson recordings. And parental engagement. So even the parents can discuss with us and let us know what they require, and they're also able to listen to the sessions and give us feedback. So the parents are also involved, and they can let us know if there needs to be any changes made. So all of those opportunities are available. And once you sign up with us, we provide a swift and a fast service. So we'll definitely get back to you with a tutor according to your requirements, and we can proceed with the lessons afterwards. So the benefits of Tutopiya. So, well, definitely they're safe, convenient, and easy. So your lessons are 100% online, and it's very safe. We are very focused on safeguarding and making sure that there are no privacy violations or anything as such. And all the lessons are real-time virtual classroom lessons, no recordings. You'll definitely have like a live lesson, and you will be given access to the recording of that lesson as well. And you have the opportunity for exchanging your homework with the tutor for any assessments. And on our platform, we have all those features available, which I will show you in a bit. And again, recorded lessons, as I said. And you also have the opportunity to provide feedback after every lesson, where you will receive a feedback form to your email inbox, and you can fill it up and you can let us know how the session went, any other areas that you need to focus on. So you definitely have the opportunity to contact us anytime. And flexible learning opportunities, as the lessons are online. And also if you have any, so our tutors actually have different time slots which you can pick from. So if you feel like there's one particular slot is not convenient to you, you can definitely look into the other slots. So there are a lot of opportunities for students. So that's about the services and benefits that Tutopiya provides to our students. And I'll just go through our platform. So let's have a look at how it looks. So this is basically the entire platform here. So so the features are, you have your upcoming sessions can be viewed once you click on upcoming sessions, and then you can look at the tutors. So you have the opportunity to look into the different tutor profiles and choose your tutors. And also you can schedule the lessons. So yeah, let's see how, yeah, so you can book your lessons actually using the upcoming feature tab. So like I said, the tutors have updated their availability slots, and you can have a look into it, and then you can decide whenever you are free out of those slots, and you can pick the slots that you're free to go ahead with the lessons. So this is how our platform looks like. And so here, once you you can look at the tutors availability over here. So you can see that the tutor is free on these particular days during these particular times. So you can choose the option that you're free on, and then you can book your lesson. So that's how it works. And yeah, so that's how our platform basically looks like. And then also you have the homework tab over here, where you can upload your homework, and where the tutor uploads their homework, and where you can actually check if there's any new notes or any new homework also updated by the tutor. And so if you go to upcoming tab, then you can see that you have been booked a class on Saturday, January 30th, likewise, and the and you have the option to join class over here. So once you select join class, it will direct you to Zoom. So currently we are doing our lessons over Zoom. So once you've clicked the join class option, it will lead you to the classroom. So these are the basic features of our platform, and it's very user-friendly. So this is just to give you an overview of the platform if you haven't used it before. Yeah, so that's about Tutopiya and the platform that we currently use. So let's look at what we have for today. So yes, so before I move on to the program content, I'd like to introduce our tutor for today. So we have Tutor Abdullah to go over the math content. And to give you an introduction, Tutor Abdullah has been working with us for a very long time. And speaking of education qualifications, he has a BSc in mathematics and a level 6 OTHM education qualification as well. And so he has 7+ years of experience in tutoring, mainly for O-levels and A-level grades. And definitely different, he's been teaching different curriculums like IB, MYP, IBDP, then the IGCSE Edexcel, and the IGCSE Cambridge. So today we'll be focusing on the IGCSE math content. So that's Tutor Abdullah. So over to you, Abdullah. I will make you the host.
Yes, thank you, Shanali. I hope everyone can hear me. All right. Shanali,
Yes.
can you hear me?
Yes. Can you?
Okay, all right. So, hi guys. Today is going to be a webinar based on algebra, and we'll be looking into the basics of algebra, as it's a short webinar today, like around 40 minutes. And therefore, we'll be looking into the basics that where you can score in the algebra section, mainly on the paper 1. So as I go through the content, if you have any questions, you can drop a chat. You can drop your questions in the chat box, and I will get back to it once we have done with the discussion at hand. Okay. Great. So let me share my screen. All right. Can everyone see it? Yeah. Okay. Hope everyone can see it. And we'll be focusing, as I mentioned, on some important topics today, which will give you some in-depth understanding towards the mechanics of how those work and how you can score on those topics. Yeah. All right. So so what would our topics be today? Let me tell you the topics today. So the topics today would be, I'm just gonna annotate on the screen. So if you guys can't see me writing, just let me know. Okay. So we'll be looking into some different topics, not at once. We'll be looking as we discuss the questions. We'll be looking into how we understand those topics. Okay. The first one would be addition, or basically operations on algebra. Okay, so we'll be seeing how do we manipulate algebraic operations. And number 2, we'll be looking into a concept called expanding and factorizing. Okay, expanding and factorizing. And then okay, so we'll be looking into expanding and factorizing. Number 3, we'll be looking into simplifying, right? So these are some of the concepts that we'll be looking at today. So these concepts, of course, will not take, these are mainly, you can see these mainly in paper 1, where you get short marks, like each would get 3 marks, 4 marks, 2 marks, 1 marks. So these kind of questions are kind of spread out all over the paper, right? This is the most fundamental understanding that you need to have in algebra in order for you to succeed in other areas of algebra. So you would ideally use simplifying, not just in algebra. You'll just simplify in anything, right? Whenever you do a question, you always simplify. Whenever you also do solve questions. Now solving not just helps you in this one, but it also helps you in when it comes to graphs, quadratic graphs, transformations. In every wherever the place you find x and y, you will need to know solving in order to find those actual values of x and y. So these are the basic concepts that we'll be covering today. And of course, in terms of the code course that we'll cover today is this webinar is based on mathematics 0580 and 0607, which there is a slight difference, but more or less the curriculum on the whole is basically the same thing, except for the fact that IGCSE 0580 is usual math exam, and 0607 would be an international math. So it's an international paper. It also has an additional paper 6. If anyone is doing 0607, they know that. But however, the content is basically the same. And also we'll be taking some questions from 0606, which is the additional mathematics, where that is just to warm ourselves up and just to challenge ourselves a bit on the topic, right? So the topic will not be different. It will be the same topic, but we'll be also taking some like around 2 to 3 questions from the additional mathematics paper just to challenge ourselves in terms of the concepts. Okay. All right. So let's get going. Right. So today we'll be on each question. We'll be looking at we'll be mentioning which past paper it is taken from, so that you can be sure of that these are actually tested questions. In fact, for you to get a better familiarity, we've actually took the past paper itself, a clipping of it, and we have inserted into the slides, so that you can actually see that they are from the past papers, and just to get the feel of how you see, how they will give it to you, and along with the mark at the end of the question. And I will, as I approach to each question, these questions are arranged in conceptual order, and therefore when I approach a question, I'll first teach you the concept, and then I will approach the question so that you have a better ground on how you understand the question. And then you'll be given tips as to how to understand the marking scheme. So why this part is important as to how you understand the marking scheme is because you don't want to write anything extra and you don't want to write anything less in your exam papers, right? You just want to write exactly the amount of answer that they give you the answer for. Because if you were to write extra, it's fine, good to go, but then you're just wasting extra time there. And if you were to miss the important parts, you might probably get a mark or 2 less than what you should have got. So ideally, you should know what their questions are and which part gets the exact answer. So understanding that is crucial as well. We will also be looking onto those stuff. And then I'll just give you some examination tips in terms of course, that when it comes to a basic topic like this, there is not much of an examination tip because these are all not much time consuming. But of course, when you go to this is a series of webinars, so we'll be looking on to more topics in the future. And when we do so, we'll be going on to some difficult areas of algebra, like creating the simultaneous equations, solving quadratic equations, and whatnot. When it comes to the sequences, we have quadratic sequences and so on. So in those cases, we'll be looking into some extra tips that exactly work on that kind of question so that you save time. All right, so let's get it going. Let's see so this is basically going to be, as I said, another past paper discussion seminar and webinar, where we'll be going. This will take a problem-based approach, right? So this will take a problem-based approach. So we will be starting with questions, and as we progress with the questions, we will also make sure that we understand the concepts. Okay, great. So this is a question taken from 2000. 1 minute. I'm just going to mute everyone for the moment, as there is some noise is coming through, and therefore if you have any questions, you may raise your hand and I will unmute you, or you can always drop the question through chat box. Okay, perfect. Right, so that's okay. Then let's just get going. Okay, right. So starting with simplifying. So if you have a look at this, we are adding some algebraic terms, and on the next question we have some multiplication of algebraic terms. So let's first understand what is the concept behind addition and subtraction of algebraic terms. And for that, I'm going to take you to a new, just a white space so that I can, scribble something on it, right? All right. So when it comes to addition and subtraction or multiplication and division of algebraic terms, there is one important concept that you need to understand, which is called the concept of like and unlike terms. Like and unlike terms. All right. So what are these like and unlike terms? When it comes to, so first of all, to understand what is a like and unlike term, you should understand what is a term in the first place, right? What is an algebraic term? So algebraic term is a term or is a combination of either a number and a letter. It's always going to be a number and letter basically. So something like this, 2x is an algebraic term. 5x, y, that's an algebraic term. Or 7x squared y is an algebraic term. Now remember that this doesn't always need to be x and y. It can be anything, a, b, c, d. It can be replaced by anything. We just replace it. We just name it x and y because we don't know what values they are. So we just use some letters to represent the unknown value. So if you take any algebraic term, the algebraic term consists of two main sections. One is the number part, which is over here. So you have the 2, you have the 5, you have the 7. You call these the you call these the coefficients, okay? These are the coefficients. And then we have the variable part, which is x, xy, x squared y, right? And we call these the variables. Now, as I mentioned, variables need not to be x and y only. They can be a, they can be b. You can even choose other languages. You can choose a Greek letter as a variable. Sorry about that. So you can choose a Greek letter as a variable, or you can choose shapes as variable, like 2 triangles plus 3 circles, something like that. It's still variables. You're representing an unknown value. You just don't know what the value of the triangle is, right? So there are variables. Those variables hold some value that we do not know, all right? And then we have this coefficient part. These coefficients, they don't change. They're just fixed, right? So 2x essentially means there are 2 x's there. So ideally there'll be an addition part, which we'll look into it later when we look into the addition part, okay? Right. So what are these like and unlike terms? So if we know what like terms are, we obviously know what unlike terms are, right? Because whatever that is not like is an unlike term. So what is like term? Like term is when you have two algebraic terms with the same set of variables, okay? So like terms can be mentioned as like term is that you have algebraic terms with the same set of variables. All right, algebraic term with the same set of variables. So what do you mean by that? Now, when you take this one, 2x, 5x by 7x squared y, what do you mean by same set of variable is that? You see the variable part, right? This is x, this is xy, this is x squared y. So the variables that in each algebraic term should be exactly the same thing. For example, I can give you some examples for like terms. If you take, say, for example, 2x and 3x, they're like terms. Why? Because the variable is x. It's the same thing. We have 5y, 7y. They are like terms. Why? Because it's the same letter. Why? We don't care about what the coefficient is. It can be anything. We don't look at the coefficient. We just look at the variable and confirm if it's the same thing, right? So if you see, then there we have another example, maybe 4xy and 7xy. See, both of them have xy, xy, right? So they are like terms. How about this one? 3 AB and 4BA. Are these like terms? You may choose to, you can just drop your answers in chat. Yes, no, any idea? Maybe a few seconds. Just tell whatever that you think it is. There is no right answer, there's no wrong answer, it's all about learning. So you just can drop your answers and see if it's correct. Okay, I'll get to the answer then. Okay, these are indeed like terms. Why? Because maybe the order is different. AB is different from BA when it comes to the order, but however, they are A and B. When I mentioned algebraic terms with the same set of variables, right? I mentioned set of variables, which means the order doesn't matter as long as the set of the variables are same. For example, in this one, we have the variables are A and B. This one is again A and B. The set of variables are same. There is no extra variable and there is no less variable compared to one another, right? So this is again a like term. And the order doesn't matter. Why? Because when you're looking at an algebraic terms, when you're looking at an algebraic term, when you say 2x, there is a multiplication in between them. So it's actually 2 times x. When you say 7x squared y, there is actually multiplication between them. 7 times x squared times y, right? You can even break this into 7 times x times y, because that's x squared is x times x. So basically everything is multiplication, but we don't write the multiplication sign. We just put them together as if they are glued to one another. But there is a multiplication. And for that reason, AB is A times B and BA is B times A. And we know multiplication is commutative, right? Commutative meaning the order doesn't matter. 5 times 2 is the same as 2 times 5. Both are 10. So the order doesn't matter here. It's just a set of variables. So therefore, these are also like terms. How about this one? 2x squared y and 3yx squared. They are like terms again. X squared and y and x squared. So the set of variables of them, we have x squared here, we have x squared here, we have y here, we have y here. So they are like terms. One more example. 3a squared bc and 4bac squared. This one, unlike the others, would not be like terms because if you see, we have b here, we do have b here, but we have an a squared here, but we do not have an a squared here, we just have an a. We have a c squared here and we do not have a c squared here, we just have a c. So the set of algebraic set of variables also means that they need to have the exact exponents for each variable. Okay, because x is not the same as x squared, a is not the same as a squared, right? So not just the letter alone, but its power or the exponent should also be the same thing. So now I hope you all have understood what like and unlike terms are. I'll give you a few seconds, maybe if you want to take a snapshot of this screen, just to save it as a note. All right, so hope you've taken the screenshot. Okay. So since you know, I'm just going to move on to the next one. Hope you've taken the screenshot. I'm going to just drop them all off. Okay. Right. And now coming back to the main question, how do we add and subtract algebraic terms? So the idea here is you can only add like terms. Okay, you can only add like terms, meaning you cannot add unlike terms. So if you have unlike terms, you just have to keep it as it is. All right. So like terms, if you, for example, 2x plus 3x. So first of all, you need to see if they are like terms, meaning they all have the same set of variables. You just have to see, confirm that first. Once you confirm that, you can add. And how do you add? You just add the coefficients. So 2x plus 3x, 2 plus 3 is 5, and you write it as x. I've seen many students who write it as 5x squared, thinking that 2 plus 3 is 5 and x plus x is x squared, which is not correct. The reason is you will only get a different power if you multiply the variables. When you add them, you don't put 5x, which is you just put 5x. This is just like you're saying, I have 2 chocolates, okay, and 3 chocolates. So say, for example, you already have 2 chocolates and I am gifting you another 3 extra, okay? Now, how many chocolates do you have? You will have 5 chocolates. You wouldn't have chocolates squared, would you? Right? So you have 5 chocolates, just like that, 2x, and I'm going to give you an extra 3x. So now totally we have 5 x's, right? And we don't put a square there. And on the other hand, if it were unlike terms like 2x plus 3y, all right? If it was 2x plus 3y, then you would not, you cannot do anything, because on the first analysis itself, you understand that they're not like terms, they're unlike terms. X and y aren't the same thing. So if they are unlike terms, you can not add them, and therefore the answer will be 2x plus 3y itself. It cannot be further simplified, just going to keep it as it is like that. And in that way, you're giving an expression. So an addition of 2 algebraic terms together like this, which you can't simplify any further, you call this an expression, algebraic expression. So it remains as an algebraic expression. All right. Awesome. Now, hope you've understood that bit, and with that understanding, we can move on to our first question. All right. So if you want to take a screenshot of this, I'm going to give you a couple of seconds here. Just snap it. All right. Great. Hope you've taken the screenshot. I'm just going to rub them off. All right. And then let's have a look at the question. All right. Simplify for m plus m minus 3m. So first of all, this is an addition. And then we have algebraic terms. Some might be thinking, okay, you told me that an algebraic term should have both a coefficient and a variable. And if you have a look at this m, it only has a variable, whereas the coefficient, right? I mean, though you don't see the coefficient, there is a coefficient, 1 in front of it. So when you say just m, it's 1m, right? It's just like in English, when someone asks you, say, for example, you have a toffee, and someone asks you, how many toffee do you have? You just say, I have a toffee, right? It's the same as saying, I have 1 toffee. It's the same as saying, I have 1 toffee. Saying a toffee is same as 1 toffee. So when it's 1, you don't just mention 1. You just say toffee, right? So just like that, when you have a 1 in front, you just don't mention it. That doesn't mean it is not 1, all right? So whenever you have a 1, whenever it is 1, they'll just give you the variable. So that means there's always a 1 in front, okay? So considering that, if we have a 1 over there, if we add them together, 4, there is a 1 here. 4 plus 1 is 5. 5 minus 3 is 2. So the answer to this one would be 2m, right? And as you can see, this takes 1 mark in your paper, right? You've already obtained 1 mark if you had answered this. Right. Next up, we have multiplication. All right, but we did not have a look at how multiplication works, because only addition has the rule. Only addition has the rule that says you only can add like terms. Multiplication doesn't have that rule. So let me explain to you how multiplication works. So when it comes to multiplication, Multiplication doesn't have that rule. For example, I'll give you an example. 2x times 3y. So if you have a look, these are not like terms, right? But doesn't matter because it's multiplication. So for multiplication and division, we don't see if it's like terms or unlike terms. Whether it's like or unlike, you can still multiply them together, all right? And the way you do it is you multiply the coefficient by the coefficient, variable by the variable. So if you have 2 times 3, that is 6, x times x, you just write it as xy. So in other words, if I had to say, you multiply the coefficient and put all the variables together. Okay? You multiply the coefficient and you put all the variables together. So what about this one? 3x times 4x. In this case, in this case, it's the same thing. 3 times 4 is 12. X times x is, you can put xx, but then it doesn't, the best way of putting it is when there is 2x, you write it as x squared though, right? Because if you can combine them, that's what we always do. We try to combine and contract them as much as we can so that it looks more simpler. So x times x is x squared. What about this? 4x squared times 5xy. Okay. So of course 4 times 5 is 20. No issues with that. X squared will only have to put with xy, right? If you see in xy and x squared, there is a x here and there are 2 x's here. So together they'll become 3 x's, meaning 3 x's meaning x cubed, x to the power 3, and then y. Because as I mentioned, you just put all the variables together. So if you were to put this, you'll just put x squared xy together, right? But x squared and x, when they multiply, become x cubed. So when the same variable multiplies, it increases the power by 1. So if I were to multiply x to the power 2 and x to the power 3, then it will become x to the power 5. They will add, all right? And if I were to multiply y to the power 9 and y to the power 4, it will just become y to the power 13, right? So when the variables are same, and when you multiply, they add. And instinctively, it works because y to the power 9 is just, so if I were to show it with the first example on how it works, how it becomes x to the power 5, is basically x squared is x times x, right? X times x. And x cubed is x times x times x. So this is basically x times x times x times x times x, which is x to the power 5. There are 5 x's here multiplying each other. So that's why you add the powers when they multiply. And alternatively, when they're dividing, y to the power 9 divided by y to the power 4, you will subtract the powers. Y to the power 5 would be the answer. You may take a screenshot if you wish to do so. And I'm going to clear this all. All right, I think you have taken the screenshot, so I'm just going to clear this. All right, so coming back here, so we found the answer for this one is 2m. No issues with that. And we're coming here now. All right, so we have to multiply them together, and you see there is no coefficient in this second term, but as I mentioned, there is always a 1. So 4 times 1 is 4, all right? And then we have p to the power 5 here and p to the power 2 here. So when you combine all the variables, it will be like p to the power 5, q cubed, p to the power 2, q to the power minus 4, right? When you combine all of them. But then you can combine each letter with its letter, right? So you can combine p with p, q with q. So when you multiply p to the power 5 with p to the power 2, when I mentioned p to the power 5 times p to the power 2, the powers will add, and therefore it will become p to the power 7. So 4p to the power 7. And then we have q's. Q's go the same way, q to the power 3 times q to the power minus 4. However, we have a negative power here, but then you still add. But remember, when adding negative and positive together, it will get subtracted because 3 plus minus 4, right? This just gives you -1. So that is q to the power -1. That's the answer for the second question on this slide. All right, hope that's clear. And you already obtained 3 marks by learning just adding and subtracting algebra, which is the very basic foundations of algebra. All right, and you will find these in a lot of other places. Like you'll find these in other questions. I mean, these are dedicated questions just to test them, but that doesn't mean these are the only places that they'll come. These will come every now and then. I mean, whenever you have an x and y to solve, you'll always go through this addition and multiplication. So this is a very crucial thing, because if not for this one, you would not be able to do any further algebraic stuff. And therefore, that is the reason why the first webinar is based on this basics. So whoever who follows the entire series will get a good benefit out of it, right? Okay, hope you've taken the screenshot for this one as well. I'm going to go ahead and erase them all. All right. Okay, so let's have a look at the next question. We have come across the concept factorizing and expanding so many times before in our curriculum. So let me give you a basic understanding of what is expanding and what is factorizing and what's this about, right? So it's it's just the same continuation. We just looked at how two algebraic terms multiply, right? So one algebraic term multiplies with another algebraic term, right? So in this case, we would just multiply the coefficient, multiply the variable, and we just put 6xy. That's done. We looked at it. Now, what if an algebraic term multiplies with a bracket? 2x times, this time it's not just 3y, it's like maybe 3y plus 2, just a random bracket, right? This is the bracket. Now, what is this? This is what you call expansion. In more specifically speaking, this is linear expansion. Okay, linear expansion. And how do you do linear expansion? So you already know how to multiply an algebraic term with an algebraic term, right? Algebraic term with an algebraic term. Now this time around, you're looking at how to multiply an algebraic term with a bracket. All right. So how do you do that? Well, let's have a look. All right. So I'm just going to move this bit a little bit to the top. Okay. Right. So how do you multiply an algebraic term by a bracket? You multiply the algebraic terms within the bracket one by one. So what you do is you will take this 2x and multiply with this 3y first. All right. Multiply with this 3y first. Okay. So when you do that, we already know what the answer for that is. 2x times 3y. So 2 times 3 is 6. X times y is xy. You have written it down, right? Okay. And then you will multiply the same 2x by the next term, 2. Right? 2x times 2. So that's 2x times 2. So that's basically 2 times, again, this is, you can also consider this an algebraic multiplication without a variable. So 2 and 2, the coefficients will multiply each other, which is 4. And this x doesn't have any other x to combine with, so that will just stay alone. So it's 4x. So you can just write it as 3xy plus 4x. All right. This is what you call a linear expansion. By the term expansion, what you're expanding here is the brackets. So you're just removing the bracket and setting them out free, right? So this is how you do a linear expansion. So you, once again, telling you just multiply the first term with the first term inside the bracket, put the answer, and then the first term with the second term inside the bracket, and then put that answer as well. All right. So that is linear expansion all about. Now, what is this factorization? Well, that is the exact opposite of expansion. So that is something called linear factorization, or basically factorization in general. Just use a different color. with green. Factorization. Factorization essentially is the reverse process of expansion. So in expansion, you remove the bracket and set them free, kind of, right? So you expand the bracket and you write it in an expanded form. In factorization, you do the opposite. They will give you this, and you'll have to put them back to the brackets again. So let's see how we do that. So we have this one. So you know how to do the expansion, the forward process, which is the expansion, where you take one term, multiply the other term, put it, and then they take the same term, multiply the other term, and put it. In factorization, you would have been given already with this one. So you start with 6xy plus 4x. And now you will have to find a way to put them back to the brackets again. And for that one, you will need to know the understanding. You need to know the concept of factors. You know what's a factor, right? Say, for example, 10. What are the factors of 10? All the ways that you can multiply and get 10 by. So 5 times 2, 10 times 1. So the factors are 1, 2, 5, and 10, right? This is the factors. In other terms, factors are all the numbers, or in this case, letters, that you can divide by and without getting a remainder. So you can divide 10 by 1, you will not get a remainder. 10 divided by 2 is 5, no remainder. 10 divided by 5 is 2, 10 divided by 10 is 10. So factor is something that will divide and divide them equally. So what you need to find is a common factor between the 6 and the 4. What number divides 6 and 4 equally, right? What is a factor for both 6 and 4? In other terms, in which times table will you find 4 and 6? Yes, it's the 2 times table, right? So in the 2 times table, you have 2, 4, 6, which means 2 is a common factor for both 6 and 4. So I would take 2 outside, all right? So from the numbers, first of all, you look at the coefficients and see what do you find common, all right? And you take it. And then you look at the variables and see what do you find common. We have x, y, and x. So we see both of the set of variables, both of the algebraic term have x, right? So x is a common variable. And then you will open the brackets, okay? So if you open the brackets, so this 2x, and you just open the brackets. And whatever that is remaining, you will put it inside. For example, if you take 6xy, 6, so when you look at the number 6, you've already taken the common factor 2. So 6 divided by 2 is 3. So what comes inside will be 3. Because only then, think about the reverse process. When you multiply it, you have to get 6, because when you're expanding, you'll essentially multiply these two together. And then you should get the 6 back. But then you won't get the 6 back if it is not 3. So that's just the reverse thinking of that. So 6 divided by 2 is 3. And x divided by xy divided by x, basically. So xy divided by x, that's just y, because x and x just will cancel out. So that's just y. Plus, again, 4 divided by 2 is 2. And x divided by x is just going to be 1, which we don't write in a multiplication. So it's just going to be 2x, 3y plus 2. All right. So it's just the same thing. You expand. When you expand, you remove the brackets. When you factorize, you put them back to the brackets again. So it's just the forward and reverse process of doing something. It's just the inverse of each other, the opposites of each other, right? Hope you understood this concept now. And I'm going to give you a couple of seconds to take a screenshot of this if needed, and I will erase them once you're done with that. All right. Okay, I'm going to erase them all. And then we'll have a look at our next question. So we have factorization here. So we just learned how to factorize stuff. So we'll do it here. So we have 21 here, 21 and 28. What's the highest common factor? In other terms, which times table will you find both 21 and 28 in? You will find them both in the 7 times table. So I'm just going to write 7. All right. And then a squared and ab, you can clearly see that a is common for both algebraic terms. If I open the brackets, all right, if I open the brackets, 21 divided by 7 is 3. A squared divided by a squared divided by a, that's just an a here. So once you've done that, you can just think about it. can just think about it. 7 times 3 is 21, 8 times a is a squared. So you're getting this term back, right? That's all you need. And then plus 28ab. So 28 divided by 7 is 4. AB divided by A is just B because A's will cancel off. AB divided by A and A will just cut off each other. That's just B will remain. So again, if you want to double check if you were right, you know how to expand. Expanding is way easier. So you can just expand and see 7 times 3 is 21, 8 times 3 is a squared. The first term should be 21a squared. Yes, it is. And the second term should be 7 times 4 is 28, 8 times b is ab, so 28ab, which is again correct. So this is correct. You get 2 marks for that question. All right. And then we have factorizing again. So let's see what we have here. In this case, if you see 2 and 5, they don't have common factors because they are prime numbers, so they don't have anything in common. And therefore, you wouldn't take any number out because you don't have, so from the coefficients, you don't have anything common, so you won't take anything common. Let's come on to the variables. So if you see variables, there's x common in the variables. So I'll just only take x out. If I take x out, I've not taken any number coefficient out, that 2 will remain as it is. And from the x, since we've taken out an x, there will be an x inside because that's x squared there. Plus, from 5x, I didn't touch the coefficient. They're just same. So I'll just repeat that. And then x is taken out common, so there will not be any x anymore. So this will be the factorization for this algebraic expression. If you want to double check, always expand it and see if it works. All right. Great. So I think this is all right. And I will move on to the next. And if you want to take a snap of it, as usual, so just take a screenshot. All right. Okay, then we have more factorization here. We have more factorization here. Right, let's see. Okay, so again, 3x squared and minus 12xy. So 3 and 12, we have 3 common. So you can just take 3 out. X squared and x by x is common. So if I take 3 out, there will not be any number in the first term, but there will just be an x remaining because there's an x squared and I only took 1 x out. And then minus 12 divided by 3 is 4. And then xy divided by x is y. So this is how it works. So by only understanding algebraic addition, multiplication, and linear expansion and factorization, you've already earned 2 marks here, 4 marks there, another 3 marks there, almost 10 marks you've already scored. So make sure that these small scores are also very crucial when it comes to exams. All right. Okay, so hope you've written it down. I'm just gonna rub this off again because I'm gonna move on to another expansion concept here. Okay, so for that I will move on to the white space and see if I can retrieve my previous note that we had. Right, there we go. We've got the note. Right. So this is what we mentioned. So we had, so we discussed that an algebraic term being multiplied by another algebraic term and algebraic term being multiplied by a bracket. Now, what if we had 2 brackets to multiply with each other? A bracket being multiplied by another bracket. Now, this is what we call, this is also expansion, but we call this as a binomial expansion. Right? Binomial expansion. Right. So let's see how do we do binomial expansion. Binomial expansion, as I mentioned, is the product between or the multiplication between 2 brackets, right? So you see the pattern. multiplication between an algebraic term and another algebraic term, and then algebraic term and a bracket, now bracket and a bracket, right? So an example would be, I'll just say 3x, I'll just choose a different color, 3x plus 2 times 2y plus 1, just for the sake of just random two random brackets, okay? Because most of them we don't put the multiplication sign in the middle, but since this is the introduction, I'm putting it, but it's fine without that as well. Usually they don't put the multiplication bracket, they just write them together like this, okay? Now, how do you expand this? Well, the easiest way of doing this, there is multiple ways of doing this. There are multiple ways, but the way that I would recommend is that you convert the binomial to linear expansion. Okay, convert the binomial to linear expansion. How do you do that? You do it like this. So you take the first bracket and you take the first term of the first bracket, 3x. You multiply that first term by the entire second bracket, 2y plus 1. All right. And then you take the second term with the sign, second term with the sign. So this is plus 2, and then you multiply with the same second bracket, 2y plus 1. So if you see here, what I've done is I've distributed the first bracket with the second one. So I've taken the first term of the first bracket and multiplied it with the entire second bracket. And then I've taken the second term of the first bracket, multiplied with the entire second bracket. If I were to show you with bracket, if this is the entire second bracket, 3x times the second bracket, and then plus 2 times the second bracket. Once you've done this, you've actually converted it to a linear expansion. Now this is a linear expansion, an algebraic term multiplying a bracket, algebraic term multiplying a bracket, right? This is two separate linear expansions. So we know how to solve it, so let's solve it. 3x times 2y, that is 6xy, plus 3x times x, sorry, 3x times 1, that's just 3x. And then we have plus 2 times 2y, that is plus 4y, plus 2 times 1 is just plus 2. So if you see, you can't simplify it any further because you don't have any like terms. This is xy, this is x, this is y, this is nothing. So no like terms, so you will have to leave this as it is. So this is how you do binomial expansion. Okay. So on that note, take a screenshot of this and we're going to do the binomial expansion question that we had. All right. Hope you've taken the screenshot, and I'm going to navigate to the question page. Right. Okay. So here we have m minus 3, m plus 2. So as I mentioned, what you would do is you would take the first term, m, multiply with m plus 2, the second bracket, and then you would take minus 3, the second term, and multiply with m plus 2. So then you do linear expansion. M into m is m squared, m into 2 is plus 2m, minus 3 into m is minus 3m, minus 3 into plus 2 is minus 6. Now, in the previous case example, we had 1x, 1y, so we didn't have any like terms. But here now we have two like terms. 2m plus 2m and plus minus 3m are like terms. Both of them have m. So we can just combine them, we can just add them together. 2m minus 3m would just be minus m, right? So the answer would be m squared minus m minus 6. You can put m squared minus 1m minus 6, but then it's the same as writing just minus m. All right, so that is how you do a binomial expansion. And that is also going to be the end of this webinar. As I mentioned, this is going to be a short webinar for 40 minutes, and I think we've already taken a little bit more than 40 minutes. But however, if you have any Q&A, you can drop your questions now to the chat box, or you can raise your hands if you want to speak, and I will unmute you. Any questions? We have Brian and we have Nilisha. No questions? All right, so I think there is no questions then, because I have not received any chat, nor have I had received any raise of hands. So that is what we have done today. So we will conclude with this today, and I'm gonna pass it over to Shinali now. Thank you.
Okay, so thank you for that, Abdullah. So I hope you all got like clear understanding of algebra and how to approach these type of questions when it comes to exams. We hope to host more webinars like this on different topics. As I said, topics that students have more misconceptions with and so on. And to those of you who participated, and we will be sending you a short worksheet with related questions, which you can try out on your own for practice. And so we really hope that you got something out of the webinar. And thank you for participating, and thank you, Abdullah, for for allocating your time on this webinar. And yes, so we hope to see you in the next webinars as well. So have a nice day, and thank you.